David Dubois brings a diverse background of skills including technical, finance, and marketing. He attended the University of Alberta in Edmonton, received a degree in chemical engineering. He has a number of years of experience developing a biomass heating sector in British Columbia, working as a project coordinator for the Wood Waste to Rural Heat project, previously the Green Heat Initiative of Community Futures East Kootenay. In that role, he conducted nearly 20 technical feasibility analyses and economic analyses of biomass heating and district heating systems and district energy systems for a variety of First Nations, local government, schools, healthcare facilities, and businesses. The systems range from single buildings to the entire heat demand of a 300-person remote First Nations community. David Dubois, everyone.
Hi everybody, thank you for coming back after supper. I really appreciate you being here, and I'm here to try and stimulate your mind and give you some very concrete ideas around what some potential options could be here in Valemount and in the Robson Valley around using biomass for bioenergy. Before we go too far, I'd like to just take a moment and say that who we are as an organization. The Wood Waste to Rural Heat project works with communities, First Nations, not-for-profits, helping them understand how they can utilize wood chips and wood pellets for heating of commercial, institutional, municipal buildings. As Owen mentioned, we were previously called the Green Heat Initiative. At that time, we were a project of Community Futures in Quesnel. We're now Community Futures Cranbrook. All that means is that my paycheck comes out of Cranbrook instead of coming out of Quesnel. I work all across the interior of BC through the generous support of our funders, and I'd just like to acknowledge the Southern Interior Beetle Action Coalition, the Caribou-Chilcotin Beetle Action Coalition, the Omineeka Beetle Action Coalition, as well as the Columbia Basin Trust and the province of British Columbia, who all provide funding for the Wood Waste to Rural Heat project. And that funding allows us to go out and do free technical assistance to communities like this that are looking to understand how they can use wood chips and wood heating for those types of buildings. One of our main mandates is to not only help you understand and learn about these, but to actually get you to the point where you're developing systems and putting them in place. I should point out we don't do any work on the residential side because that's a fairly well understood sector. We're primarily looking at the institutional, commercial, and municipal sector. As an example, we've recently completed a business case for Clearwater to look at putting in a biomass heating system for their new municipal office and community building that they've just purchased, and potentially looking at connecting heat customers to that. We're working with Barrier on a project where they have a new wastewater treatment plant where they'd look at putting in a biomass heating system for that. Before I get too far, what is biomass heating? Pretty straightforward, using wood chips or pellets to produce hot water. Not steam, hot water. These are just examples of some of the different projects that are out there. In the top left, you've got Enderby, which is a privately owned district heating system, financed by a local supplier of biomass equipment, who went out with his own capital and installed a heating system. At full build out, he's gonna have approximately 12 clients. Baldy Hughes on the bottom left, out near Prince George. Some of you may have heard of it. It's an old military base that was converted to a rehab facility. They removed the old oil boilers, put in a new wood pellet system. The top right is a remote school west of Williams Lake called Tatla Lake. That's a 100 small system inside of a 20-foot container. That system is actually controlled and monitored out of the school board office in Williams Lake over the internet. Biomass heating is not a beehive burner. It's not really an outdoor solid wood boiler either. What we're talking about is clean, efficient, effective use of technology to produce high efficiency results with very low emissions. A lot of times I'm talking to people that aren't really familiar with forests. I'm dealing with engineers who build buildings, civil planners, etc. So we like to go through, and this is an example of a woodlot in Europe. You can see the wood here. This is what they would call their pulpwood. Send that off to be pulping for chips. In the back, it's kind of tough to see, but that's their wood that's going for specialty dimension wood. In the back, that's all their bioenergy. What they'll do is they'll chip it to this type of material here, load it in the truck, transport it 2, 3, 4, 10 kilometers to the local school, the local village, and burn it for heat. Very simple, nothing too complicated. This is an example of an in-bush chipping system. We're not talking the large-scale chipping operations that people are familiar with around this country, where they're bringing in these huge multi-million or million-dollar machines that are going through tons of material at a time. This is driven off the PTO off the back of a tractor, going into a walking floor that goes off and supplies a heating system. So one of the questions that we always talk about is, well, how much do we need? And we've heard the discussion here. You know, we start to talk about thousands of tons, et cetera, et cetera. So just to give people some scale, if you look at a typical pellet plant, they consume roughly 500,000 tons per year of biomass. A lot of times I have a tough time. How much is 500,000 tons? So I drive up and down the highway all the time. I see B trains. That's give or take 12,000 B trains per year. Typical large volume power plant will consume about 5,000 B trains a year. Recently, BC Hydro had a call for electricity for a 5 megawatt maximum system. It's kind of tough to see there when you're comparing it to the pellet plant and the power plant, so I've blown it up. It's about 1,000 truckloads, give or take round numbers. The Enderby system that I showed you, heating 12 buildings, takes the equivalent of about 20 truckloads. So just think about within our area, when we're having all these discussions about how much fiber availability there is, et cetera, et cetera. How much is 20 truckloads within this community? Well, slide didn't get relabeled. That should say Valemount current energy costs. My apologies. What's the cost of energy? People don't realize how valuable wood energy is. So if you go and take a look, and we always base everything in comparison to natural gas. Nakusp doesn't have natural gas. Valemount doesn't have natural gas. So let's look at electricity. If you go and look at your bill, by the time you add in, your delivery charges and everything like that, you're paying around $24 a gigajoule or the equivalent, which roughly equates to about 8 or 9 cents a kilowatt hour. If you go and compare that, if you're using propane at around 75 cents a liter, that's around $28 a gigajoule. If you go and buy pellets in bags at a ton from the hardware store, that's about $10 or $11 a gigajoule. If you're buying wood chips and you're paying somewhere in the order of about $100 a ton, an oven dry ton, that's $5 a gigajoule. Anybody know what the current price of pulp chips is here in this area? What they're getting for them? Not having to ship them all the way to Kamloops, using them here. I know in Clearwater there's guys that are saying, you know what, if I could get $1 a ton, $2 a ton, I'd be happy. And they'd supply that all day long. So that's the opportunity. So when we're talking about district heating, there's lots of different components to it, and I don't want to get too complicated about how to do it or anything like that, but I just want to highlight some of the business parts of it, because what's interesting for small communities is there's a real opportunity for a business to be part of this. Now, is the municipality part of that business? Potentially, yes. As a client, maybe as part of the ownership structure. Maybe it's completely private, like Enderby. When we're looking at it, there's sort of 3 aspects to doing district heating, or just even single building. You have your fuel supply, you're producing your heat, and you're doing it to your distribution. If we go into the electrical supplied, this is your reservoir, your dam, your wires. Very simple. Except with biomass, you're collecting your fuel, wood chips or pellets, you're combusting it to produce hot water, putting it through water lines to the different buildings. The business could be each one of those individual components, could be a combination of 2 of them. So for example, what a lot of models are is that you have a fuel supplier supplying to a company that will combust it, produce heat, and distribute it throughout the community. Or perhaps it's something where it's your own fuel supply that you're combusting and selling it. Is that a role for the community forest? Maybe. So there's some different, we've talked about what's happened. There's a few different ways to look at it. You could have, public ownership, which would be the village, the regional district, the province, federal government, public entity. Or it's a private ownership. Maybe you have somebody with a vested interest, such as in Enderby, where they've got somebody that sells heating equipment. Maybe you've got a company that's producing their own fuel that they want to figure out a usage for it, so they're going to sell it and produce their heat. Maybe it's a logger, a woodlot, etc. Or more than likely, it's probably going to be a combination of both. Maybe there's a community forest in there, a not-for-profit, or maybe even a for-profit venture. So to give you examples and translate this into something real world, and I'm using Enderby because it's a really neat model, because it broke a lot of molds. Traditionally, district heating systems have been developed by governments, and they haven't been super efficient because nobody really cared about the cost. And then you had a fellow by the name of Burkhard Fink come along and say, I'm going to do this, because I've seen this in Europe. He's European. He knows what can be done, and he just went ahead and did it. Used his own money, put in a small 540 kilowatt boiler, about 600 meters worth of trenching, and he's using about 800 tons per year of biomass. Originally, he couldn't find anybody to sell him his biomass because nobody was really interested. So he ended up getting it. I don't know if who knows where Enderby is, but it's north of Vernon. He was originally using clean construction debris from the landfill in Penticton, because he couldn't find fuel. Once he's up and running, there's a sawmill about 5 kilometers away from Enderby that's producing, small-scale sawmill, that's selling him all the fuel that he wants. High-quality fuel. So that's just a picture of the boiler there. This right here is his ash container. Cleans that periodically. That's the front of the boiler, and that's me standing in it just to give you some scale, and that's Burkhard himself and his salesman. That's the layout of the grid. That's that 640 meters that I was talking to you about. Another system a little bit closer to home, Lillooet. Lillooet, once again, a community that's on propane. They were heating a recreation complex, including a swimming pool, arena, and library. They put in a 400 kilowatt pellet boiler and did a bunch of other mechanical upgrades as part of a project called the Green Energy as a Rural Economic Development Tool project, which some of you guys may have heard of. We did a detailed case study for it. And these are the results. Total capital cost was about $705,000. Interesting thing to bear in mind is that the boiler part of that was only about 300,000 of it. The rest was additional upgrades inside of the building, so it didn't really factor in. They got about 2/3 of the funding from gas tax, the rest was from their reserves. So just looking at the boiler itself, total capital cost was about $400,000. District of Lillooet put in the equivalent of about $140,000. Right now they're saving $26,000 a year on pellets. That's based on propane at 46 cents a liter. After we did the analysis, they came back to us and they said, you know what? We're actually probably on average spending closer to 52 cents a liter. Based on those numbers, you can see that they had a payback of around 5 years. If they were to do it without any grants, even with the high price of propane, payback is 16 years, which isn't great, but it's still fairly something that could be recognizable. And an important thing to keep in mind with this is, because this was such a new thing that had been done, they had to do some additional Ministry of Environment permitting that was required. That was an extra $4,000 each time that they did it, because they didn't really fit into a nice category. That has since changed, so these economics would look even more favorable. This next project is in Grand Isle. I'm not sure how many people know where Grand Isle is. It's halfway sort of between Burns Lake and Smithers, and then about 45 minutes north. It's the end of the road. They had a fire hall there of about 2,200 square feet. They put in a wood chip boiler, put it inside of a 40-foot container. The village did all the groundworks for the foundation for the container and build the roof, and they put it in. Total capital cost, $61,000 for that whole boiler. Once again, about 2/3 from gas tax funding, 20 grand from OBAC. And then because they were able to project manage it themselves, they show an in-kind contribution of about $6,300. It's worthwhile noting that $55,000 in funding paid for them to do a bunch of the work, to do the groundworks and stuff like that. So what does it look like? Well, saving about just under $4,000 a year. Payback is less than 2 years with the current grant structure. If they would have done it without grants, it probably would have been about 16 years. But don't forget, they also paid their own people to do some work. So that's sort of the biomass to heat side. That's my specialty. That's what I do. A lot of times people, when they're talking about biomass and bioenergy, they think of electricity, and so I want to give you a bit of a flavor of what that looks like right now in British Columbia in the context. And this is what I will call the significant scale. This isn't the small scale stuff like the Lillooet or Grand Isles. This is the larger. But right now, there are only 3 operations producing electricity from biomass that are not pulp and paper related. So they're not tied to a pulp plant. One is Atlantic Power in Williams Lake, which was installed to deal with all the waste and eliminate beehive burners. Then you have Louisiana Pacific in Golden, another community that doesn't have natural gas. And then Tolko has a standalone facility in Armstrong. The rest there, you can see the list of pulp plants. Now, when you're going from biomass to electricity, there's a lot of different things that are being in development, which I think is really important for Valemount to be aware of. So West Fraser and Chetwynd and Fraser Lakes are in the middle of doing a development project where they're installing organic Rankine cycles, which is just a technology to convert heat into electricity. Those are part of the BC Hydro call for power. West Fraser has 3 in Quesnel. The 2 really interesting ones, and I kind of alluded to them a little bit earlier, was in Fort St. James and in Merritt. There's a company called Dalkia. Has anybody ever heard of Dalkia? Dalkia is a company based out of France. They're a utility company. They do electricity, they do heat, they do district energy. Their total sales for 2013 were over 8 billion euros. Billion euros. BC Hydro for this year is going to be about 4 billion Canadian. So these guys are big players. They're coming into the market, they see the opportunity, and they're installing biomass to electricity standalone facilities. They recognize that opportunity. They're going into the markets where they realize where the fiber basket is and they design accordingly. The other ones on the bottom there, those are just some of the different pulp mills. The Fort St. James project is actually in construction right now. They've just recently started construction. The other one, the Merritt project, they're just waiting for financing. They're dealing with a number of different international funding, so they're just waiting for that to all be in place. So in order to be able to sell electricity, there's 2 ways that you're able to do it right now within BC Hydro. There's the standing offer, which is for projects above 50 kilowatts to a maximum of 15 megawatts. The other one is net metering. Net metering has been designed for home solar panels, small run-of-river. The third one is integrated customer solutions. So there's one in Nechako, Vanderhoof Lumber. They put in a small ORC to displace their own electrical consumption on the grid. They're not actually technically selling it to BC Hydro, but they're displacing BC Hydro power. Currently, those projects are receiving somewhere between $100 to $130 a megawatt hour, or 10 to 13 cents per kilowatt hour. When you're talking about the standing offer process or the integrated customer solution process, it's a long process. Think years. BC Hydro is not somebody who moves very fast. They have very expensive requirements before they will let you put a wire onto their stuff. I'm sure there's many people in this room can have some very strong discussions about what it's like to deal with BC Hydro. All right? So let's talk about Valemount. Narrow it down. What could we do here? So, I don't know if anybody saw me when we pulled into town. I'm thinking, let's take a look at this. So I go on Google and download a map. This is where we are right now. You guys know the layout. So we put a heat plant here. And what's it look like? Well, I'm going to roll the dice and take a guess. This looks like it's about this big. Probably going to take about 10 to 15 B-trade loads to heat the elementary school, curling rink, arena, this building, and the building next door. I'm guessing, and I don't know, I'm sorry, I can't remember. Angela? Anne. I put her on the spot, asked her how much they pay for propane for these buildings, and she's going, well, I don't pay the bill, so don't know. But I'm going to estimate that it's about $20,000 to $50,000 a year for the propane for these buildings. Yeah, so, anyways.
Basically, David, you're replacing 11 propane tanks, 1,000 liter propane tanks.
Yeah. So like, please don't look, these numbers are meant to give you scope, idea, right? So you're talking about a boiler probably similar to what Lillooet has for their arena swimming pool complex. About 300 meters worth of piping. Capital cost to put it in, 300, 600,000, somewhere in that range. Probably below $1 million quite easily. Competing against propane at $30 a gigajoule or 75 or 80 cents a liter. Probably looking at about a 5 to 10 year payback. I'd like to say that as an organization, the Wood Waste to Rural Heat Project, we'd like to help. We'd like to help you guys understand if that's an opportunity that you guys want to pursue. You know, and if you are, I'd encourage you, let me know. Did I mention that our services are free? So I'll kind of leave it at that. I know people are kind of tired, but if anybody's got any questions, feel free.
Yeah. How are you drying the wood chips?
Don't need to. Depending on, different boilers will use different moisture content wood chips. If you're using what they call a wet wood chip above about 35–40% moisture, you use one style boiler. If you're below 35% moisture, then you're using a different kind of boiler.
But can you mix it?
What's that?
Or we're going to throw off the boiler?
You can mix them, but if your boiler is designed for 35% and below, then you can only add in so much wet chips before you get above that. And different things happen technically. If you have too wet a fuel, then the boiler doesn't get enough heat. It's not as efficient, you get more emissions. Or if it's too dry of fuel, it gets too hot and it burns out your boiler. And so those are some of the technical things that...
Can you use hog? No, you don't. Go ahead. Can you use hog fuel or is it just chips?
You can use hog fuel or chips, but what you have to be aware of is if you go and try and put hog fuel into a boiler design that's, let's say, really small, by the time you put on an auger big enough to make sure that it's not going to jam up because you got 6-inch long sticks and everything like that, it's going to be 3 times as more expensive than what the boiler is. So you use a fuel that's according to your boiler. Most of what we're talking about in this scale of projects, I always tell people, think something like a pulp chip. If you get above sort of 1 megawatt larger range, then using hog fuel is probably going to be more appropriate. With that being said, if you were to take your hog fuel, do some screening on it, you know, and take out the overs, then you'd be fine.
Yeah, it was used in an arena project. How did that work? With the arena making ice, or just heats the portions of the building that needs to be heated?
Anytime, anywhere that you need heat. So let's say air makeup from your kitchen, heating of hot water for your ice resurfacing. Burns Lake put hot water heating into the stands of their arena. They got water lines going up and down on the seats and you're standing on them. Haven't heard how well that's doing, but you know, those are all potential.
In this free service, so one of the things we're also interested in doing in Valemount is geothermal.
Yep.
And with the opportunity, there's some arenas that are
Yep.
geothermal to cool ice service. Are we able to mix and match here a little bit and use some of the expertise in terms of system design?
So my expertise is not in geothermal, but what I can say is if I go through and develop a business case for a biomass district heating system, if you go and say that the district heating portion, we substitute a geothermal heat plant instead of a biomass heat plant, you know, that's kind of a, you'll be able to use some of that data interchangeably.
And, sorry, so you said B trains at 12,000 and 100 tons. I'm totally confused. So when you said for this, how many, you said 18 B trains or something like that per year?
Yeah, something, that's, when I say, you know, that 10 to 15 B trains, that's, it's probably in that range. It's not going to be 1 or 2, but it's also not going to be 50 or 60.
Right.
You know, it's...
Power Brothers produce, what can we get in terms of chips from them? Darren? We don't make chips.
You guys get hog fuel, right?
Yeah,
You must
that's what it would be. You could put a chip right now.
Yeah.
Yeah. You'd probably get, so your spinning plant.
8 tons? 80.
80 tons, how much? A year? There's 25 oven dry tons in a B train. So how many truckloads?
We're talking for Dale is about 800,000 tons.
Sorry, how much, Mark?
I can't remember the numbers. We figured it all out here a couple of years back for the people in McBride.
Yeah.
It's about 11,000 tons.
Yeah. So I'm going to guess that you're going to use 5% of that.
Other markets available for shipping, say, train cars?
The challenge that you run into is that it's a very light fuel. So if whether or not you're shipping wood chips down to Domtar, it's the same thing as shipping pulp mill for fuel. You know, there's a limit, and it relates to how far you can ship it, regardless of the mode. That's how come they take wood and they compress it into a pellet, is to reduce the amount of volume and get a higher energy density.
Is the pellet supply saturated at the moment? Like, it seems like it was 10 years ago, a bunch of mills put in pellet plants.
Right now, to give you, if you go to Europe right now, and you go to Austria, as an example, a very specific example, and you go to the typical business person that's doing something and they're going, I've got a big building I'm trying to heat. So I've got 2 choices. I've got my forestry that's out back. No, it's not going anywhere. I know the guy that owns it. He's not going anywhere. That's really secure in their mind. I buy natural gas, I buy propane, that comes from Mr. Putin. I'm not sure how many people think Mr. Putin is really secure right now. We have a different mindset. We have this availability of fiber. There's still lots of opportunity. If you look at various studies within British Columbia, just / available at roadside, the number in BC is somewhere between, you know, I see numbers 7 million bone dry tons per year to 30 million bone dry tons per year. Total pellet production in BC right now is about 1.5 million tons per year, and that's existing production. So we still got lots of room for pellets, lots of room to develop a pellet market, but that's kind of not really related to this. It'd be the same thing as, would you go and dig your own oil well for diesel? It's kind of like these types of systems use fuel that's already processed and everything like that, so.
Canadian biomass, I think we quoted their article several times, they're predicting a 10-fold increase. Then Korea just comes on and saying they're going to use 4 times more than they have been using in the next 2 years.
Yeah.
Because they're going all biomass, and they're not going to use any petroleum.
Yeah. If you were to look around here last year, there was a large number of Japanese people that were coming over looking at biomass because they've got nuclear reactors and they've had a little problem with those. So there's opportunities. Then you start to factor in the the carbon cycle and what that's doing in terms of driving production, and the discussion around the carbon neutrality of biomass and all those sorts of things. So there's a lot of things that are really driving this, and there's lots of opportunities, and there will be growth. For sure.
There's a plant in Merritt that was down but never started up really, and it's just going to start up now.
Yep.
And they're going with torrefied pellets, and they're going to be supplying the pellets to for the cement business.
Yeah.
In place of gas.
There's coal.
And coal.
A word of caution about torrefied wood pellets. I'm not sure how many have ever heard of that term, torrefied wood pellets, torrefaction. It's been something that's been kicked around. People in the bioenergy circles have been talking about it, and it's a real good opportunity. There's a number of reasons why they're doing it, but the long and the short of it is there is only one commercial plant in the world producing torrefied pellets right now, and they are struggling to find a utility to take the product on a regular basis. There's no off-sales agreements or anything like that. So there's been a lot of talk about it. A lot of people are trying to fix it and want to do it and everything like that, but it's not actually in the market just yet. But it's close. 6 months, a year and a half. So
One of the attractive things is the oil byproduct. They can still use the pellets.
that's a different process when you're starting to get into pyrolysis in terms of how they're separating out the wood into the different product streams. And there was actually a company in McBride that were looking at doing some stuff around the biochar. And
In our labs, we've got something going on in Quebec in the lab on that.
yeah. So, and there's lots of opportunities, and it's all about taking the wood and being able to take the energy that's in the wood and condense it down as small as possible so that you can ship it to the rest of the world. Because there's a huge demand. We don't realize here in Canada that we have some of the lowest prices of energy in the world, and we have multiple abundant sources, whether it's hydroelectricity, natural gas, fuel oil, all these different things. We're actually really quite spoiled compared to the rest of the world. So.
Well, the ethanol producers in the States that are producing ethanol from corn are saying they can't afford to give the corn away for free, to the people because it just wouldn't work. It costs so much to...
That's a whole, and there's a whole question going on around that, around use of biomass from food sources for fuel and whether that's appropriate and everything like that. Within the European context, they have moved towards outlawing biofuels from food sources. Yeah. So. Yep.
Do you know of any cogen plants that operate without a major producer of fiber right next door?
So sort of.
That's our problem here. We need some way of getting rid of this fiber, but we don't have mills that produce the biomass to supply it. So we would have to go and, log the majority of it, bring it in, chip it, and then feed this thing, right?
Well, you wouldn't be logging for energy. You're still going to be using, if you're going out and you're harvesting the wood, you want to use the stuff that's already at roadside. It's like anything else. Once it's already at roadside, you've already paid a lot to get it there. So how do we utilize that? How do we stop from burning it? And it's about what's the existing infrastructure like right now and designing your plant based on that infrastructure. Right? And what's the number that, I think I heard somebody kick around a number, 50, 60, 70,000 tons per year in the area. So you would design a plant that would consume that 50, 60, 70,000 tons per year of biomass. You wouldn't want to go and say, we're going to put in a plant that needs 300,000 tons and then go out and harvest just for bioenergy. Bioenergy production is always a byproduct of other forestries. It's the lowest value product, so it's always got to be in conjunction with other forestry. That other forestry can just be primary harvesting, but you have to do that as part of that initial harvest and bring it to the roadside, put the infrastructure in place to be able to do that.
You don't want to subsidize your cogen or pellet or fiber industry with your logging revenue, right? It has to support itself though, so it doesn't work.
Okay, but here's the question. The question is, I understand what you're saying, and that's what people talk a lot about. When you're saying subsidize, if you look at your fiber basket, and I'm getting, you know, $60 worth of saw logs, and I'm getting $5 worth of pulpwood, and I'm getting $3 worth of energy wood, and I'm getting $10 worth of, you know, whatever that product is. If you look at that total revenue from that block, and from there you go and say, okay, I have to then take that revenue and I have to pay my civiculture and all that sort of stuff. So it's just another value stream that you pull out there. You're not going to go and say, okay, well, bioenergy is going to pay the same portion of roads as lumber, because lumber is going to generate far more value, but it's a proportional amount. But you have to include that into the
Different way of looking at it to do that.
Yeah.
So how much do you have to pay the ministry for that?
That's a different kettle of fish, and I'm not going to go down that road. You'll have to ask the foresters.
Making profit, they want their share, to be sure of that.
Well, at some point they will mandate, though, that why are we burning this and wasting it in the bush? We want you to dispose of it in a better manner, and if you can utilize it and if there's a market for it, it will get there. A lot of the majors have been hesitant to do it right now because it is extra cost, because traditionally they haven't been in the energy sector. But as an example, Canfor now, I was talking to somebody from Canfor, was in one of the meetings that I was at, they were going, they are no longer using any natural gas to do any kiln drying. All their kiln drying is coming from hog fuel. They are looking at bioenergy from their waste material as a means of generating additional revenue. If you were to ask me that question 3 years ago, none of the majors would have had that on their radar. Now they're all looking at it as a complementary and necessary part of what their business model is.
That's part of the problem here, is, as the gentleman down there pointed out, there's no plant here.
Are they just starting a carbon process?
But they've got bush grinders.
Yeah.
Their businesses around going out collecting fiber. Like that's something that could happen here.
Yeah.
Just to summarize, we're not going to get rich turning wood waste into electricity. We're going to lose less money by shipping some of the wood waste that we have around to heat and not pay for propane.
Yeah, you are gonna make money, because what's gonna happen is, instead of spending $50,000 a year on propane that leaves your community, you are gonna spend $30,000, $40,000, maybe less, to have somebody harvest that fuel, somebody else process it, somebody else deliver it. It's a very localized economy for energy.
And I think, like, as a community, because we're forestry based, I think we should enact a law here that it doesn't need to make money for the community until it's cost neutral with propane, because just on principle, we shouldn't be supporting oil companies or other ventures that are outside the valley, right? Just say, it doesn't matter if it's cost neutral. With the cost of servicing the debt or whatever else, you have to factor that in some way. We just say, no, this is good because it keeps local machines and people going, even if it comes out as cost neutral propane.
I'll tell you what, in Austria right now, as an example, Austria is very similar to Valemount, mountainous regions. You know, forestry is a strong part of it. They have over 1,500 district heating systems. The vast majority of them, over 1,000 of them, are less than 1 megawatt. They are 102 kilowatts to 1,000 kilowatts, i.e. this size range that you would be looking at here. That is supporting their local forests, and they do it because they see an opportunity to generate additional revenue from their forest streams. And these guys aren't, if anybody who's worked in Europe, they're not the most efficient way in terms of going out there with these big machines or anything like that. It's hand falling, it's expensive, but they make it work. And they make it work because their cost of energy is high, and the cost of energy here is high when you're looking at propane and electricity. And so it would work here.
Electricity here, if you look at your power bill, you're paying on your lowest rate, I think it's 6.7 cents a kilowatt. But that's going to go up by a factor of 2 within the next 5 years. And, you know, in Austria and in Sweden, where they're taking 18-year-old trees off plantations, taking the whole tree, wrapping it up, the whole thing goes to the power plant. And so they're making sense with their electricity charges by taking the biomass before it even gets to be a piece of wood or lumber.
That,
and it makes sense.
and that's a whole other thing when you start to look at doing that plantation crop. And I would say, do you know what? Plantation crops would be great if it wasn't for the fact that we have local biomass within 5 or 10 kilometers of our community that we're not even using.
Yeah.
You know, so let's use that first and then figure out how we grow more of our own.
It's gonna get better.
Yeah, yeah. So,
But you would get enough just in scrap piles, and all you need is a chipper and a dumper.
pretty close. It's a little bit more complicated because you got to make sure that you get the right fuel quality and everything like that, but that's fundamentally what it would be.
I'd love to hear a description of what that process is. Do you need a covered area to store all these chips and make sure they're dry?
So, sort of getting down the path, the technical side, what happens is your fuel supply, there's different standards. We're developing a standard here in Canada based on what size of equipment you have in terms of what the particle size of your fuel is, what the moisture content is, et cetera, et cetera. And so that will govern. So from there, you take that fuel and you put it in your storage. Typically, what you're doing with your storage is you're protecting it from moisture. That's all that you're trying to do. Once it's whatever moisture content that it's at, that's where you want to keep it. So you've got a cover over top of it. You've got a smooth floor such as asphalt or concrete, so you're not picking up gravel or anything like that that's going to contaminate your boilers, cause you problems. From that storage system, it gets fed into the boiler automatically. You don't have somebody there with a shovel going like this all day, right? Fully automatic.
That's a job.
It is a job, but that's not a job I want. So it feeds into the boiler automatically, operates with minimal amount of operator input. For example, the system in Lillooet, the guy's looking at it maybe an hour or two a week. From there, it goes into the boiler, produces hot water, not steam. Steam requires steam tickets, complicated, expensive. Hot water, nice, simple, easy, piped out to the buildings, same pressure as domestic water system. Goes through the buildings like this in radiators, various types of things, in-floor heating, et cetera, gets cooled down, goes back to the boiler. A lot of times what the best practice is to have a big hot water storage tank. And that relates to when you've got a boiler, there's mass to it. It's big and heavy. When it's operating, you want to operate it as warm as possible so that you're as efficient as possible. And you're maximizing your fuel usage and minimizing your emissions. So you've got a hot water storage tank that's associated with it that you heat up, and that goes out to your buildings. That protects your boiler as well and deals with some of the different fluctuations throughout the day. You know, everybody wakes up in the morning, and if they're like my kids, they have their 45-minute shower and I have a 2-minute cold shower. So you've got your hot water storage reservoir there that can deal with all those different daily fluctuations and with what the heat demand is throughout the year, et cetera, et cetera. And that's sort of starting to get into the technical side of designing.
Let's do it.
Done.
What did you say, the proposed one for Belmont,
That's me sitting on my, I would say, you know, it's a $500,000 project. It's not a multi-million-dollar project. It's something that I would say would be doable for a community.
So you get 2/3 of that back from the gas tax?
Well, depending on what the municipalities, how they're doing with their gas tax, what that allocation is, the majority of the systems that are being done by local governments, et cetera, have been funded from their gas tax monies.
Has anyone that you know of approached the insurance people in the country to exclude pellet-fired furnaces and like automatic systems from their ratings? Because even if you have a pellet stove today, the insurance companies will charge you as much as $500 a year more for insurance.
Yeah.
And it's not warranted because they're all as safe as oil or gas.
Insurance companies are, and you're right, and that's one of the challenges on the residential side when you're using wood heat. Traditionally, what happens with wood heat is people are using old systems because they're very efficient. The design approach is different than these European systems, and it relates to how you're getting the heat out of it and everything like that. And what happens is people have chimney fires, they don't do the right amount of maintenance, all those sorts of things. And so when they look at their actuarial tables, all these things show the insurance company wood-based heating is bad. Oh, by the way, it's not inconsistent and you need some form of a backup. So that's why they push up the rates. A lot of what we're talking about for the commercial institutional buildings, typically what's happening is that you're having these installations separate from the building to, you know, a sea container that's off a corner of the property, something like that. Or, you know, if you are going to put it inside of the building, you're making sure you're putting the proper fire breaks. You're not just doing it on the...
But if the insurance companies put out a list of criteria that you had to meet to get the lower rate, then don't you think that that would be good for safety of the people and plus for the industry?
I think that would be a great thing to do, and there's a group called the Hearth and Barbecue and Pellet Association who deals with residential heating appliances, and they have been doing some strong lobbying to the insurance companies and the governments to help differentiate between these different types of systems and all that sort of stuff. But let's face it, insurance companies don't like to lower their rates if they don't have to.
They got a good thing going, so they...
Well, they can justify, so it's hard to get them to change sometimes.
Is there a good example of something that we could tour?
What do you see? What do you want? What's your qualification of a good example? Like a system in place that you could go and see that here's a district heating system that works? Yes.
That would be similar to here,
And-
both in like, you know, for like this area here, heating this, and then maybe some industrial, like on an industrial site.
Yeah, so if you're interested, by all means, let me know. There's Enderby, there's Lillooet, there's west of Williams Lake, there's some schools, there's up around Prince George, Fort St. James, there's a cluster of buildings there. Probably in about 8 or 9 months, you'll have Barrier, potentially Clearwater, maybe within the same time frame, potentially. Oh yeah, like I would Clearwater is already, my understanding, and I could be wrong on this, but my understanding is they're very strongly in favor of going forward. They're looking and going through the process to incorporate it into the renovations that they're currently doing on their building. That includes trying to source out how they're going to pay for it and stuff, but yeah. Yep.
The cooperative, somebody mentioned that, do you know of any examples of that sort of multi-use space? I was in another conversation, it wasn't me that was talking about it. But Craig was asking about industrial systems that probably may include more than one industry. Do you know of any of those?
Yes. It's not that uncommon, for example, that you'll have, you know, a pulp mill that'll pump heat to somebody else, another business. It's pretty standard on an industrial complex. It's just about the scale, typically, is the challenge, you know, so.
You got the big unit in Prince George, Canfor, right?
Yeah, that's one of those big, you know, 60 megawatt industrial steam generators. Oh, you're talking about the Prince George District heating system. That's an interesting system because what it is that's actually, it's waste heat. They had their kilns, they put in a new boiler on the kilns. Conifex did put in the new boiler, I think it was Conifex. Is it, who's this? Sinclair, I can't remember what the mill is. But they put in a new boiler, and what the company says, we want to put in this new boiler, we'll sell you heat from the new boiler, and in order to improve emissions, you guys put in an electrostatic precipitator to reduce the emissions. So actually what happens is the district, or the city of Prince George does not produce heat. They buy heat from the sawmill.
You know, these power plants, is there quite a bit of energy required to run those?
Yes.
And where does that energy come from?
Electricity. A lot of it comes from electricity. The other thing that they have a large requirement for is drying. When they're pelletizing, they have to get that material down to, 8-10% moisture, and typically what they'll do is sometimes they were using natural gas, more and more are moving towards using some of their own fiber to do that.
Yeah, are they using hog fuel then
Yeah.
to produce the
Some of the-
energy for the drying?
Yeah.
And then the sawdust and whatnot goes into the pellets?
Yeah. So if you think of a typical sawmill, and there's examples of this in Europe, you've got your sawmill generating sawdust and hog fuel. Adjacent, what they'll do is they'll put their hog fuel on a conveyor, send that to a cogen facility that's producing heat and electricity. The electricity is pumped back to the sawmill as well as to a pellet plant to take the dried sawdust and compress it. And so it's a real closed loop kind of a scenario.
That's like an L&M, but I don't know, are they making electricity there?
When I mentioned the ORC at L&M, that's the one that they just came online in the past 8 months. L&M is Nechako lumber / premium pellet / something or other. There's another, yeah.
They use their hog fuel to run the energy system for that. Pellet plant.
I'm not sure of how I don't know the specifics of what they're using and what the exact fiber flows are and everything like that, but I do know
They're
that,
making electricity, but they're certainly using the hog fuel.
yeah, I think what they're doing is they're taking the waste heat off their kilns to heat oil that they are then using to put through the ORC, so it's waste heat to produce the electricity.
Yeah.
I
Oil
think.
is a much more efficient thing to heat up than water is.
The biggest reason why you go to hot oil is because it can go at a higher temperature.
That's right.
If water above 100 degrees Celsius, it boils and turns into steam, which is really hard and expensive to deal with. Hot oil can get up to, 300 to 400 degrees Celsius and not have to have a steam ticket or whatever. So that's how come a lot of the mills have gone to hot oil kilns.
Kind of oil is that?
I'm not sure. Special thermal oil.
It'd be
It's,
very expensive, but it wouldn't break down. It would be a high-grade oil, you think.
I'm going to guess that it's not cheap and it's not exactly the 10W30, but I don't know any more of the details. Yes.
Do you have a cost analysis comparing to disintegrating and burning your waste to get rid of it compared to this? Like, to me, there are very few BI burners are even allowed anymore.
Yep.
And so your option would be scrubbing or, there's actually quite a bit of technological input to dispose of waste legally in most places. So do you have a cost comparison? If you're just burning the waste with scrubber type system as opposed to this?
I'm not sure what you mean by burning the waste with a scrubber type system.
Getting rid of waste legally without meeting emission requirements and such is not actually cheap in a lot of places. Like a lot of meat pipe burgers are already expired.
Yeah. Okay. So when I'm talking about those systems, to give you some scale of how efficient they are
Yeah.
and how clean they are, if you take a look at a typical old style fireplace, you go and you cut that emission to a 1/10, give or take. That's a pellet stove. You take that 1/10 and you cut it down about a 1/4, and that's some of these systems. When they're operating, a lot of times you're going to see, all that you're going to see out of the stack is if it's a wet fuel, you will see water vapor. If it's pellets, all you'll see is a heat shimmer. So these things are that clean that you won't see any emissions coming out of them.
That's the burner design though, because you're actually evaporating the moisture out of the fuel as you're burning it.
Yeah.
And the burner design has to be designed with that in mind. And that's why the moisture content threshold is 50 minutes.
Yeah, and that's when we're talking about different moisture content boilers. A boiler that uses wet fuel will be much bigger because you have a larger fuel volume because you don't have as much energy per cubic meter of fuel. So there's a bunch of different characteristics around that, as well as making sure that you get the proper retention times, and there's all sorts of different things. And that's how come these boilers are why I call them sophisticated. You know, you can go and buy an outdoor solid wood boiler and somebody's gone and taken some steel, welded together, and you throw a match and fuel in there and it burns. Yeah, it's a boiler. These, they've looked at it, they're looking at how the fuel falls and moves through the grates. They're looking at how the gases inside flow around, how you're maximizing residency time, how you're creating a whole bunch of different factors. So these, they look simple, but they're not. You know, is the long and the short of it.
Does it make sense to you to use hot oil in your circulation system in your boiler to heat the hot water in your water heat sink in order to keep the heat sink smaller?
No.
No?
No. The idea why you have the heat sink is that when you start your boiler, you maximize the amount of energy that you're getting out of the boiler. So it doesn't really matter what that fluid is, because, you know, when I'm talking about a heat sink, it's a very large volume of water we're talking. You know, in a small system, it could be 200 or 300 gallons of water. Like, it's not a little amount of water. There's certain ratios and design ratios and parameters that they typically use for that sort of thing, but yeah. It's just, a lot of times what they'll use is a specially treated water so that you don't have to worry about corrosion because of the mineral content and everything like that. But that's starting to go down that fairly technical path as well.
The roughly 500 K that you quoted for the, I mean, I realize it was very rough quote, but
Yeah.
what would that all include? Boiler, piping, building upgrades?
No building retrofit. It would depend on what's inside. So for example, this boiler, or this building here already uses hot water heat. What's that?
Done.
Little wee heat exchanger the size of an on-demand hot water tank in the basement replaces whatever boiler system, hot water heating system is in here.
Yeah, all of these buildings.
Yeah. Yeah. So in that case, very little retrofit costs. You know, when I say that number, I'm putting out a number that's going to be, that's not going to be a building for your boiler. That's not going to be a LEED Platinum building. That's a container. That's a 20-foot shipping container. You know, if you needed something from an aesthetic point of view that our community, you know, we've put in a bylaw that we've outlawed shipping containers, then maybe you put the container and then you put a shell around it to hide what it looks like, or you do a custom design building. But it's a very simple sized system.
Is it safe to put next to the school?
Yep.
Is there any,
There's, it's no different than if you were to put in a gas boiler. You know, how many people have burned their eyebrows off with their propane tank? You know, it's the same thing. If you operate something and you bypass the controls, bad stuff happens. But these things are designed to rigorous standards, to CSA standards, so that doesn't happen. You know, there are literally hundreds of thousands of these types of systems installed. This is not, you know, somebody in the backyard tinkering away or anything. It's a good question though. Like, you know, that's what people, this is, when I talk about combusting wood in this manner, people know what combusting wood is. I've had a wood stove forever and a day. I know how to burn wood. And you're right. This is taking wood heat and putting it through a supercharger and doing it completely different. When you burn wood in your wood stove, you're driving along in your Ford, right?
Great.
Sorry. This is driving along in sort of a supercar.
So Ford.
Okay, a Fiesta versus a Mustang. Anybody else?
So for that 500K, you're just doing 2 or 3 buildings.
The most expensive part is actually, you know, when we're talking systems of this size, once again, some general numbers, the boiler is about 1/3 of the cost. The miscellaneous fuel handling building is about a third of the cost, and the piping to get to the various connections is about another third of the cost.
If you're only good for a certain distance, then you gotta put up another building.
No. You're not, let me rephrase that. You are right. There's a certain distance that you can go before you have to put up another building, but you are talking kilometers. So for example, if we look at the typical heat pipe that you'd be using here, you'd be seeing 4 or 5 degrees of heat loss per kilometer of pipe.
Okay, before I just understood the pipe, you can only go so far before you lose your.
You can only go so far with the piping because it becomes too expensive. That pipe there, some of the numbers that you're probably beginning to be looking at, by the time you put the pipe in the ground, et cetera, it could be $300 or $400 a meter. There's some places where it's over $1,000 to $1,200 a meter.
So you could you do it in 2, 3, 4, 10 different stages?
Yeah, you can, depending on how far you're going. And that's part of the analysis. For example, you put it in here and it all works great, and then all of a sudden, by the way, 2 hotels over there want to connect. So then, okay, you run your line and away you go. So there's the ability to do that.
But then you'd have to have a boiler big enough to do it.
You'd want to have the infrastructure, your fuel handling infrastructure and your building big enough, but not your boiler. Because if you have too big of a boiler, then it operates inefficiently. So what you do is you design basically for the existing load, and then you have infrastructure available that if you need to, you can just plop in another boiler, connect to your fuel supply, you've got enough room in your building, all those sorts of things.
So I don't know how you figure out what you need.
Well, you design to, who are you going to have connecting to the system? And a little bit of extra on top of that, 5, 10, 15%, whatever that number is. And then once it's up and running, and if somebody wants to connect, it's like anything else. Okay, there's a limit. I need to get an extra, 100 kilowatts of capacity before it makes sense for me to connect to you. Once you build up that much capacity and people that want to connect, that's when you do it. And maybe that's one client, maybe that's 3. That's part of the analysis that you sort of go through. There's different ways of measuring, the amount of heat that you're selling per meter of trench per year. There's a bunch of different parameters that you look at to determine the worthwhile.
How big a storage building you need for fuel next year?
Typically what you're looking at is, we usually say about 3 weeks or 1.5 times the size of your delivery vehicle. So for example, if you're using a dump truck, you'd want enough, so I've got enough to operate my system and have some chips in the bin and enough that I can take a full truckload. Or enough to operate for 3 weeks at full load, assuming that 3 weeks over Christmas, let's say you're not going to be able to get any fuel.
So that means the fuel's coming direct from Wish to house storage?
Yeah, depending on what's that?
I guess it doesn't have to be dry either, does it?
No.
Set up a system.
Depends on what you design your boiler from. It comes from wherever, once it's been chipped, that's when it goes into the bin. If you're chipping in the bush, then you can bring it right into the bin.
But at different times of the year, you'd have sometimes wet and sometimes dry.
So then that's when you'd have to be doing some fuel blending, and that's, you might be stockpiling. If you're chipping in the bush, let's say, what you'd do is you'd leave it in the bush and let it dry as much as you could. Then once it's dry, that's when you'd chip it and then bring it in. You wouldn't chip it to dry it. You'd wait till it's already dry before you chip it. Let's say if you were to go and say, you're harvesting a block that you're going to use for your fuel, you might stockpile it off-site somewhere simply because you're processing a year's worth of fuel at one time. Well, if you've got a year's worth of fuel that's 3 times the size of this room, the logistics of having a building that big enough to contain it, it's not economical. So you've got to take a look at that as part of your fuel supply and manage that accordingly, depending on how much you need.
If you had a building that was big enough to store dried fuel, it's dry enough to burn, then whenever the fuel is naturally dry, like in a dry create a weather, you can just chip it all up and put it in there.
Yeah. Once again, it's an additional cost depending on what the infrastructure, where you're getting your fuel from, you know, that you'd want to take a look at. And those are some of the specific questions that you'd want to have answered when you're going forward. And
Because we all got something to sleep on, eh?
thank you very much. And if you think of anything else, by all means, just, you've got my information. I think these presentations are going to be made available to you. Send me an email, give me a call, send a pigeon, let me know.
To wrap up the evening shortly, I'd like to open the floor to questions, comments, and I kind of want to start the discussion with what is the what and when is the when, and go from there. What do you guys want to see? What do you guys want to, you've seen what we have, you've heard what we have, you know what we can do with it. Mr. Olson was here, we'd have some really cool international trends, which I cannot do that justice. You've seen some manufacturing guidelines. You know the cost in which it takes in order to open a manufacturing and to improve current manufacturing here in the Valley. So again, I pose the question, what is the what and when is the when? I mean, these are we have challenges and we have solutions to think about. David?
I've got a question or a comment or something I'd like to put forward. We've got a lot of people in the room right now that have expressed an interest. I would like to put forward, you know, what would you guys want to have happen? Would you like this group to come forward again now that you've had a chance to process? Give yourself some chance to process and come back with some additional next steps.